Hi guys, so this is a requested video. Basically it's going to be about the sensors and that you use for auto watering. It's going to be quite a longish video, so what I'm going to do is do it in 3 parts. So obviously you can take the part, if you already know how to use the sensors, you can totally skip that and obviously watch the second part for the rest. These are the 2 different types of sensors. This one here comes with this, which also has a digital output, which is this one here. So we've got plus, minus, digital output and analog. We're only using the analog, so I've made up this little clip so I can easily connect it to the board. We're also using the Geekcrete, something like that, board, because obviously we've got all these expansion ports. We've got male and female headers, and we've also got these extra headers here for voltage. So first things first, we'll use this sensor first. We need to get some base values from it first before we can actually use it. So I'm going to connect the negative and ground over here, the 5V and ground, sorry, and then we're going to obviously clunk the analog in on analog 0. So we've got ground, 5V, analog 0, and it's the same thing that's coming out of here, plus, minus, and analog 0. So the first thing we do, we need a dry value of this sensor so I can actually map the values and make them functional. So first thing we need to do is, if we the valve, we'll call it sensor. We're also going to need we're going to be using the serial monitor to get our values, so we need serial.begin. We'll set that to 9600, and also we need to set up our pin mode. So pin mode, that's going to be A0 because that's what we're using, and then we want that as an input. Okay, so now we'll go down to the void loop, and in here obviously we need to print out the value, but first thing we need to do is we need to obviously get these values from the sensor itself. So what I'm going to do is I'm going to do in fact that's going to be for the map, so we'll not have to do that yet. We'll do sensor, and that's going to be equal to analog read A0. Sensor equals analog read A0. I need to come below that, and we'll do serial dot print ln serial dot print ln, and we're going to print sensor value. Okay, so we'll upload that now, and hopefully we should get some values out on the screen. Okay, so that's the top end. Now these 2 sensors are different in the values you're going to get. This one and this one here, this capacitor. This is the better type because it's got no physical contact with the water, whereas this one here, over time, I don't know whether it's because of the material itself, but they actually they start to soak, which will give you like false readings, which is obviously not good if you want a really reliable system. They will work temporarily. I've used them outdoors in a planter, and the base after they work fine for the first day, but then once they start getting a bit soaked, I mean it could be something to do with the ground in itself, but I found that, I don't know whether it was charging the soil slightly around the area and adding capacitance to it, but I found that the day 2 and day 3 the pumps were just turning themselves off and going a bit whapper. Now that could be a number of things. I never actually got to the bottom of it, but what I did do is switch to these, and I've never had a problem with these at all. So we're getting these values. So that's a top end value. So now we need a lower value. This is obviously the dry value. We need a wet value now. So I'm going to just put some tissue around this. This is slightly damp because I've had to do this video again, but I'm going to add a bit more to it. Obviously want it to be as soaked as possible to know, should you have a really heavy rain, especially in the outdoor conditions, we need to know what the very, very top end of the dampness is. So it's saying 430, but I have actually seen these go lower than this. So what I'm going to do is I'm going to map that down to 330, because obviously we don't want any false triggers. If it goes negative, it will false trigger and turn on your pumps. So what we're going to do is I'm just going to add here 2 lines. So we'll start with a dry value, which was 1024. But I'm going to map that to 1030, so there's no possibility of it going over that value. And the bottom value, I've seen it as low as 330, so we're going to do 330 and use them as the values. That's a dry and that's a wet value. I've commented these out, so obviously I can still upload the code and not have any issues from these because they're not being used at the moment. They're not implemented. Okay, so what we could do is map these values now and make them usable. So what I'm going to do is drop that down, come back here on INT. We're just going to use I for now, and then that's going to be equal to the map value, which we're going to set. So map, and the way we want to map it is you want your dry value last. So we'll put our wet value first. No, sorry, dry value first. Sorry. Because we want to switch these values around. So 1030, and then we want 330, and then we want our new values. So I'm going to do it in a range between 0 and 100, and then that should give us some usable data then that we can use within a range. Obviously to print that value out now, I need to change this here, the analog read. That needs to now be I. It doesn't matter if that's before that or after, but what I'm going to do is I'm just going to copy that now, delete it, and I'm going to put it above it just to make sure it's always getting the latest values. So I equals analog read, and it's going to map them values. I think there is a way where you could put that analog read in here as a reading. I think also actually I think there might be a different way I can do this. I think if I put I in there, I like so, I don't know if that's going to allow me to do it, but I'll try it anyways. Let's just get rid of that and put sensor. I'm not sure if this will work, but it might do. I can't remember, there's different ways of doing it, you see. No, it's not going to bring up I. Oh, hold on. It might still work actually. Let's see. Let's see. It might be an easy way of doing it. Yeah, I think that's going to work. Yeah, it is. It's working. Yeah, so we can just put that I value straight in here, and then obviously read it straight to the sensor. I was going to do it slightly different, but there's no need for it, so we won't do it that way. Let me bring that back before the OCD kicks in. So now, as you can see, obviously our dry value is 1, so obviously that's going to be dry. It won't go any lower than 1, or at least it shouldn't. Now we need to see what our wet value is now. I'm just going to put a bit more moisture on that. I don't think it's quite wet enough. This is obviously going to be sopping wet. It's not going to be what you're going to be watering your plants to. Obviously if you've been watering plants manually before, you're going to have a rough idea of what your top and bottoms are anyways. Just move that out of the way. So top end of this now is 85, 86, so it could probably go up to about 90, and obviously our dry is there. A middle, let's put some on the one side, so it's probably about half, so we say about 50. But what you have to do is, once you've done this, you're going to have to obviously stick this in your soil for your plant, and then you want it to let your plant go to where you'd normally it'd be dry. You'd consider it dry, and then you'd water it. Take that value before you water it, and then when you've watered it, give it a while for the water to soak into the soil and see what your top value is. Give it like 20 minutes, 30 minutes, well, probably 20 minutes will probably be fine actually, but give it 20 minutes and then see what your wet value is, because they're the values you're going to be using then in order to make sure you're getting enough water in your plant and you're not over watering it. Otherwise it's going to be a case of hit and miss, and you're going to have to keep, you know, slightly adjusting everything. That's that part of obviously getting your values and mapping them. I will do this sensor. The only difference between this one and that one is the readings are slightly different. I don't think the range is as big as what this one is. This one's range is probably within about 300-400 of top and bottom. I will cover this one should anyone need it, but I'm actually not going to bother at the moment because it's going to make the video too long. So what I'm going to do is, this is going to be in either 2 or 3 parts. I'm going to do it, and then that way you can just go through straight to what you want to do. So for the first part, obviously using the sensor and that, I'm pretty much considering this done. What I will quick do is, obviously, to add functionality to this, obviously we know our top and bottom. There's an LED on the board there, so we use the LED on the board. For some reason it's already turned on. So what I'm going to do is we'll go to setup, digital right, that's 13, so 1.3, I want that as an output. I don't know why that's on. It might be something changed in the Arduino code. Let me just quickly upload this and see if the light goes there. If it doesn't, we'll digital write it. Oh, that's the wrong pin mode, that should be. I don't know why I did that. Pin mode. There we go. That'll help. Hopefully it should go low, but I don't think it will. Oh, it has. Yeah, it's gone low. Oh, that's alright then. So the pin mode's turned the LED out, this one here. So that's good. And now we can use that just to highlight, you know, the values. So to basically use this as it is, we mapped the values between 1. So see, the dry value, you see your plants are never going to be dry. There's always going to be a bit of moisture there. That's why you need to actually stick this in the soil to get your, these are just base readings we've taken, just so we can map these values down into obviously the 0 to 100. Obviously our lower one now is that, and our top ends all wet. It's going to be 90. That's when it's fully wet. Like say your bottom end is going to be probably around about 15, let's say. So your dry value, I'd consider it about 15, but it might be higher than that. Like I say, without putting this probe into the soil, you're not going to know that. And I'd have it turn on around about, let's move that over. So I'll say about 50. That might be too much, you see. It might be 45. Obviously you don't want your pump to overwater, because when it switches off at 50, it's going to probably go up to about 60, or somewhere in between 50 and 60, so it's going to go over. And obviously we don't want to be overwatering our plants. If you can take them proper soil readings, like before you water it, so let your plant go to where you'd normally decide to water it, put your probe in the soil, take that reading, that's going to be important, write that reading down, and then after you've watered it, like I say, put this probe, or leave the probe in the water, it doesn't make no difference, and then take your reading, and that'll give you the closest possible readings you can get to making that do exactly what you want it to do without you actually having to water the plant itself. So obviously to use that now, it'd just be an if statement like before. So if this then that, basically. So we'll say if it's dry, so we'll say 15. So if sensor we might need to range this, so we'll say less than, so we're going to do less than 15. Okay, So if sensor's less than 15, obviously we want the pump to turn on. So the pump being, it's going to be the LED, so it's going to be digital right. Oh, digital right, and then there it's going to be 13. Oh, and then high. Okay, and obviously we don't want it to turn off in between that, so then we want a second one, which is if, same again, so if sensor more than is what we're going to be using this time, which is that arrow. What did I say it was, about 50? So if more than 50, that's when we want this to turn off. Like I say, these are only theoretical readings, because like I say, in a real life scenario these values will be different. So I wouldn't just take these base readings, plug it all up and add pumps and all the rest of it and just let it go. Like I say, it's important that you do take your actual readings from your sensor in a real life scenario, like say it's in the soil with your plant and so on. So we'll quickly upload this now, and then we'll see what happens. So obviously we're less than, so that's the lights come on, which is telling us that the pump's on. Obviously we've got our values, so let's try and keep these values up. Oh, that went straight over. So as you can see, it's because it's gone straight over the value, and I want to try and creep the value up if I can. So there, so we're slightly under 15, so obviously our pump's still on. We'll come over 50, you see, and then it's we'll go back down again, pumps back on, and then pumps off over 50. And that's basically what's going to happen. When it's dry or under 15, it'll turn on. When it's over 15, it'll turn off. Now I could add a relay to this, but there's no point. Basically when that light's on, this is clicked, so it click over. So if you're looking at your relay board here, you always use your COM and your middle one. This one here, NC, is normally connected, so when this relay's off, the latch inside here will be connected to this one, so them two will always be connected. So it's the normally open, which is the NO2, and the common that you want to be using. So all you'd do is you'd take either you can either use your positive to your motor or your negative to your motor, but one of your wires basically wants to go in here. So it's the positive, then you want to put your power positive into this one here. So then when it clicks, it basically creates that loop, so it's going through the motor and you've got your negative and your positive supplied. That's basically how you use it. You don't put a negative and a positive into this, because as soon as that clicks over, it'll short out. It's just one of your wires you'd use, so there's no point in doing that. You can always simulate it with just an LED, and that's what I'm doing here. So yeah, I hope that helps, and I'll for anything else, obviously we're going to connect the rest up. I will do it. I will connect obviously the relay. I have got a pump here I can use to show you how that's wired, so that's going to be in the second part, and we might use this at some point, but I'm not sure. There's no real difference. It's the same thing. You can use the same code to read this as what you're reading this with. It's just that the values will be different. So thanks for watching. Subscribe, like, and check out the description if you want to get hold of any of these boards. I've got some links in there for these boards and a few other things that I recommend that I normally buy, things like that off eBay. So yeah, thanks for watching. Like, subscribe, and see you in part 2.